Given a recurrence relation, a starting term, and then a way to get from one term to the next. So we can just let n be different values. In fact, the first thing we want to do is let n equal 1, because then the left-hand side becomes u2. That's the one that we want to calculate. And then it's equal to u1, so our current term, plus 7 cos pi over 2, because n is just 1 here, minus 5 minus 1 to the 1, which is just minus 1. And then you'd put n equals 2 in to get the next one, n equals 3, and so on. We can just build our sequence from there. So for u2, we're going to get u1, which is 35, plus 7 times cos pi over 2, then minus 5 to the minus 1. So very similar to what I just wrote above. I've now substituted the u1 in. Cos pi over 2 is actually 0 because our cos graph looks like this. So every time it's pi over 2 or 3 pi over 2, we just get 0. That's gone. And therefore, it's 35 plus 5, which gives us our answer of 40. By all means, put it in your calculator. If you do that, just make sure you're working in radians. Okay, it's not said out loud, but it's implied by the fact that there's a pi there. When you do cos of pi over 2, you get 0 like that. But you can substitute the whole thing in if you want. No worries. Okay, u3. That's going to be u2. I'm now letting n equal to 2. So 40 plus 7 cos, then it's going to be 2 pi over 2, which is pi, minus 5 times minus 1 squared. So actually that becomes 1. And we are actually going to be minusing 5 rather than adding 5. Now cos of pi is actually minus 1. Again, by all means, put that in your calculator. So it's going to become 40 minus 7 minus 5, 40 minus 12, which is 28. And then u4 will be 28 plus 7 cos 3 pi over 2. Again, that will be 0 minus 5, then to the minus 1 to the 3. That just becomes minus 1. I'm adding 5. I'm going to get 33. I hope you're on board with that. Given that the sequence is periodic with order 4, write down the value of A5. So what this saying is actually we've got 4 terms, and then it repeats. That's what we mean. Periodic with 4 terms, then the same 4 terms, and so on forever. Which means that u5 will be the same as u1. It's going to be 35. It's actually not a bad idea to just check it by substituting it into the formula, because then we can be really confident with our part A1 as well. So it would be u4, which is 33. I'm letting n equal 4 here. So plus 7 cos 2 pi, which actually is 1. And then minus 5 to the minus 1 to the 4. Actually, that's just going to be, I'm just going to be minusing 5. So I'm going to be doing 33, that's 1. So 33 plus 7 to give 40 minus 5 gives me 35. That's just a little check by putting it into the formula. We don't need to, but it means that we can be really confident with U3 and U4. And then finally, we're asked to find the value of the first 25 terms. So what we actually have is 35 plus 28 plus, wait, I've missed the 40. 35 plus 40 was the second term, plus 28 plus 33, and then again, and so on. There's 25 terms. 24 is divisible by 4, 6. So I'm actually going to have 6 lots of this. Okay, because I'm going to be adding 4 terms and the same 4 terms, the same 4 terms, 6 times. That'll take me to 24 terms. And the last one is going to be back to being the first term. So I'm going to be adding 35 on. That's what you're expected to do in this question. Recognize that it's repeating. We know the length of repetition is 4. You could even do 25 divided by 4. You're going to get 6 remainder 1. So we've got 6 lots of this 4. And then I've just got this 1 at the end, which is back round to the beginning, the 35. Put that into a calculator and we are finished. If you're really not sure, look, you could write out all 25, but that's not really what it's aiming for you to do. It wants you to recognize this. So by the way, it's neither an arithmetic or a geometric series. Okay, it's not, it's just repeating. And this, yeah, it's just a slightly different take on series and using summation notation. And we get 851. Bam.